right, so today we are in lesson 13-2. So if you haven't already, your book should be open to page 217. So yesterday we looked at the situation with the salon, and we solved this system that you see right here in example A. We solved that graphically. So we used our graphing calculator, we found intersection points, and we solved it graphically. And this was the supply and demand functions for a quantity of haircuts based on the price X. So today what we're going to be focusing on is solving those systems where one of the functions is linear and one of the functions is quadratic algebraically. So it's the same exact function. We already know what the answers are from yesterday. Here it's just writing out and telling you the steps when we're going to do that algebraically. So step 1 says use substitution to solve for x. So what they're doing here is, because this is a y and this down here is equal to y, they're putting the 1/10 x squared minus x minus 5 in place of y in the first equation. So it's saying substitute for y in the second equation there. Now, I would like you to write out to the side here, because usually that's not how we describe this process, because we'll use this same process for all kinds of functions later this year, and for that matter, the rest of your math career. So cubic, quartic equations, all of those things. So next to use substitution to solve for x, set the equations equal to each other and solve for x. I can't write on this. I can only write on the PDF, so I can't write on the web page. But go ahead, right next to this where it says use substitution, write set equations equal to each other and solve for x. Because that's what we're doing. These rules with the x's are both equal to y, which means that they're equal to each other. So that's how we typically describe it, even though it's the same thing. Saying use substitution isn't wrong. It's just that most of the time you hear it said, set the equations equal to each other. So you can see that they did that here in this first step. Then they got the equation in standard form, because this is going to still be a quadratic equation. When you have one quadratic and one linear, the quadratic term is going to stay for sure. So get it in standard form, so you can see that. So get it equal to 0 next, and then you just solve the quadratic. So they chose in this specific instance to get rid of the fractions by multiplying by 10, because that makes it standard form, and then they used the quadratic formula. Again, you can choose any method that you want to solve the quadratic that remains. So if it's factorable, you could factor it. If not, you can complete the square or use the quadratic formula. If you happen to have one that doesn't have a linear term, you could use square roots. But notice that these are the exact same solutions for x that we got yesterday when we solved graphically. Now, that's step 1. Set the equations equal to each other and solve for x. Step 2, it says substitute each value of x into one of the original equations to find the corresponding value of y. I would change what this says here, and I would say plug x values into the linear equation, because all of the systems we're looking at here are one linear and one quadratic. It is much, much easier to plug a value into a linear equation than it is to a quadratic equation. So they did choose the linear one, but I would actually write that in step 2. Instead of saying into one of the original equations, I would say into the linear equation. So you can see that's what they did here. They plugged each of those x values in, found the y's, and then step 3, we'll leave it like it is, write the solutions as ordered pairs. So there were the answers we got yesterday, and again, like we talked about yesterday, only one of those answers actually makes sense for the real life situation. So we tossed the other one out. It is still a solution, It's just not one that we list when we interpret the solution. So if it just says solve, you need to list both. If it says, solve and interpret, then we'll toss out the one that doesn't make sense. So we're just going to go through a couple of these. In the Try These A on page 218, we're going to do part A together here. So as I look at this, step 1 that we wrote on the previous page was to set the two rules equal to each other and solve for x. So for step 1, set equal to each other and solve for x. So what's that look like here? That's taking negative 2x minus 7, setting it equal to negative 2x squared plus 4x plus 1. And now I'm going to solve. So that means that I want this to be in standard form. So it doesn't matter which side you move things to. I prefer for my squared term to be positive. So I'm going to move things to the left in this case. So I'm going to add these three terms, so add, move that over, add 2x squared, and then subtract 4x, line it up under its like term here, and then subtract 1. So all of those will cancel with our opposite operations, and we're left with 2x squared minus 6x minus 8 equals 0. So first thing that I would do is look to see if it's factorable, because if it is, then that's going to be my easiest bet. So there is a GCF of 2, so factoring, we always do GCFs first. So that would leave me, after I take out the 2, with x squared minus 3x minus 4. So since the leading coefficient is 1, I'm asking myself, are there factors that multiply to negative 4 and add to negative 3, which the answer is yes, obviously. Negative 4 and positive 1, so that means x minus 4 times x plus 1 is my factorization, which means my two solutions for x are x equals 4 and x equals negative 1. So that's step 1. And then we're going to plug the x's into the linear equation to find y. So when I plug in 4 into the linear equation, I get y equals negative 2 times 4 minus 7. So that's negative 8 minus 7, which is negative 15. In the other solution, y equals negative 2 times negative 1 minus 7. So that gives me positive 2 minus 7, which is negative 5. So step 2 is done. Step 3, didn't really leave myself quite enough room here, is to write as ordered pairs. So my ordered pairs here, when x was 4, I got negative 15, so 4, negative 15. And then when x was negative 1, I got negative 5. So these are my two ordered pairs that are solutions. Remember, any solution that you get, if you plug them back in, they should work. So if you want to double check, you could plug the x's into the quadratic and make sure that you get those same y's. Because if you don't, either you did something wrong when you plugged it in, or you didn't solve it correctly. Okay. So I would like for you next to try part D on your own. So follow these 3 steps. First, set them equal to each other, solve for x. Then plug those x's into the linear equation to find your y's. And then list your answers as ordered pairs. So go ahead and pause the recording here to give yourself time to actually solve this. Okay, so let's check your work. These ones didn't come out evenly, so you've got radicals here. So first step, set them equal to each other. So negative 4x squared plus 5x minus 8 equals negative 3x minus 24. So first thing I'm going to do after I set them equal is to get it into standard form. So again, it doesn't matter which side you move things to. I just generally prefer for my x squared term to be positive. So I'm going to move them to make that so. So I used all my opposite operations, so these have gone away. So I've got 4x squared minus 8x, and then minus 16 equals 0. So first thing I would do is see if it's factorable. So there is a GCF of 4. So if I take the 4 out, I've got x squared minus 2x minus 4. So this one is not factorable because when I look at it, I see that there's nothing that multiplies to negative 4 that adds to negative 2. So that means I need to choose either completing the square or the quadratic formula. It is up to you. Because b is even, I'm going to choose completing the square, but that's up to you. So if I'm going to complete the square, that means I kind of crossed this out because that was factoring and it didn't work. So I'm going to first move my constant over. So 16 on the right side. Then I'm going to factor out my a again. So x squared minus 2x. Then I'm going to add blanks on both sides, and I fill in the blank. Negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. So that's my blank on the left. On the right, I have to do my swoopy multiplying thing. So that gives me 4. So now I factor as a PST on the left side, so x minus 1 squared. On the right side, 16 plus 4 gives me 20. And then next, I'm solving, so I need to divide both sides by 4 to get rid of that first. So I've got x minus 1 squared equals 5. Then square root both sides. So I've got x minus 1 equals plus or minus radical 5. And then finally add the 1. So I've got x equals 1 plus or minus radical 5. Remember that these are two separate solutions. So when I go to step 2, which is to plug those solutions into my linear equation, I plug them in separately. So I'm going to do y equals negative 3 times 1 plus radical 5 minus 24. And then the second one, I'll do y equals, sorry, my equal signs look weird, negative 3 times 1 minus radical 5 minus 24. So then obviously I would distribute here, so negative 3 minus 3 radical 5 minus 24, which gives me negative 27 minus 3 radical 5. Over here, when I distribute, I get negative 3 plus 3 radical 5 minus 24. And when I combine those, I get negative 27 plus 3 radical 5. So when I set up my ordered pairs then, when x was 1 plus radical 5, I got a y of negative 27 minus 3 radical 5. And when x was 1 minus radical 5, I got negative 27 plus 3 radical 5. So hopefully you came up with those solutions. If you didn't, obviously you can correct your work with what we did here. All right, we're going to look at one more of these together. So this is number 1 on the same page below the try these. So same idea. First thing I'm going to do is set them equal to each other. So 4x plus 24 equals negative x squared plus 18x minus 29. Then I'm going to get it into standard form. So add x squared, subtract 18x, add 29. So those are all going to cancel. And I've got x squared minus 14x plus 53 equals 0. So, in order for this to be factorable, I would need factors of 53 that add to negative 14, which I'm not going to be able to find. This is not factorable. So again, you can choose to complete the square. You can choose the quadratic formula. Does not matter at all. Again, I usually choose the completing the square if b is even, but you are more than welcome to use the quadratic formula if you want. So I'm going to move my constant to the right side. And there is no a to factor out, so that means I just go right to my b divided by 2 squared. So negative 14 divided by 2 is negative 7. Negative 7 squared is positive 49. Because there was nothing to factor out, which means it was a 1, that means this one is also a 49. So then factor on the left side, that's x minus 7 squared equals negative 53 plus 49 is negative 4. So then square root both sides. X minus 7 equals plus or minus 2i, because it's a negative under there. So then add the 7. I get x equals 7 plus or minus 2i. Again, remember that these are separate solutions. So when I go to plug them into the linear, I plug in the plus once, so 7 plus 2i plus 24. And then I do the same for the minus. 4 times 7 minus 2i plus 24 as well. So now I need to distribute. So I get 28 plus 8i plus 24. And then when I add those together, I get 52 plus 8i. Over here, same thing, except I've got a minus sign, so 28 minus 8i plus 24, which gives me 52 minus 8i. So, ordered pairs, 7 plus 2i was my x, 52 plus 8i was my y. Over here, 7 minus 2i was my x, and 52 minus 8i was my y. So these would be my answers here to number 1. All right, turn the page to page 219. And number 2 asks you to describe the solutions of the system of equations that we just did here. So think about it for a second. And what would be the most appropriate description for those solutions that we have there? So hopefully you decided that you either said that the solutions were complex or that they were imaginary, which is the type of solutions that we have. So if you wrote that they are imaginary or they are complex, that's great. I also want you to add the system has no real solutions, because I want to point that out. Because if we talk about number 3, confirm that the system of equations has no real solutions by graphing it on the graphing calculator. How does the graph show that the system has no real solutions? So if I pull up my graphing calculator here, and I'm going to graph the system. Okay, here's my graphing calculator. Go to my y equals. Oh, notice I've still got an inequality there, so if you still have inequalities from when we graphed those the other day, go ahead and change that back to an equal sign. So it doesn't matter which one you put in y1 and which one you put in y2, but if I put in 4x plus 24 in my y1, then I've got to move this up here, negative x squared plus 18x minus 29 for my y2. If I hit graph, I can see my line, and I can see only part of the parabola. So that means I need to adjust my window. So I'm going to move my x's to 20s and count by, oops, not 2, 20, and count by 2's. I'm going to make my y's, let's go negative 70 maybe. Ugh, what is wrong with me today? Negative 70 and 70, counting maybe by 10s, and see if that's any better. We may have to adjust again, we'll see, but we just want to make sure that we have a good looking picture. We got it. So if you look here, we'll look on the bigger one. You can see that when we graph this, there aren't any intersection points. So that is the answer to number 3 there. That how does the graph show that the system has no real solutions? I would just put there are no intersection points. So you can see that solving graphically doesn't always work. That's why it's important that we also know how to solve algebraically, because we can't always use the graphical solution. If it's a real life situation, we can, because we know that if the solutions are imaginary, that they don't make sense for a real life situation. But when we have just the algebra, we do need to make sure that we solve algebraically if the graph shows that there are no real solutions. All right, so that is it for that lesson. Make sure you look at your syllabus because I did not assign all of the problems from the practice for your homework.